morning, guys. Today we are going to go over just this quick PowerPoint on the Hertzberg-Russell HR diagram. Okay, it's just going to kind of give you an overview and hopefully help you dive a little bit deeper into it. Yesterday you read an article to give you an introduction into it, and today is just a little bit different way to present the information. Okay, as you watch this video, you are going to be completing the Google Doc that I sent you. Okay, I even spelled it out for you. I have it right here in paper form. Okay, you are going to go slide by slide. After every slide, pause the video, go back through. If you have to rewind it, but most of it can be found in the actual slide. You're just filling in the blanks. Okay, you can delete the underlined lines and type right in it. Okay, and then you're going to click mark as done when finished. So let's get started. So this is the Hertzberg-Russell diagram. Okay, the HR diagram is a chart that graphs the star's brightness and temperature. Okay, so everything on this diagram is going to show you the properties of stars. It's going to show you their brightness, it's going to show you their temperature. As you move to the left side of the chart, so closer to the y-axis, your temperature is going to get hotter. It's going to increase. Okay, as you move up, your temperature is going, or your brightness is going to increase. So the top left of your graph should be the brightest and the hottest star. Okay, the bottom right of your graph, let's see if I can find the bottom right of your graph, should be the dimmest and the coolest star. Okay, the category or type of star is generally included. You have your main sequence, supergiant, giant, and white dwarf. So again, just to model, you would go to your notes page, pause this video, and literally all 4 bullet points, you are just filling in the correct answer. Okay, and there's one more bullet point on the bottom. So the color of stars can also be represented from hottest to coolest. You have your blue, white, yellow, red, orange, and red. Okay. All right, moving on. Next slide. Main sequence. So this is slide 3, main sequence. 90% of the known stars are in the main sequence stage of their life cycle. Okay, so the majority of stars are going to be found in that main sequence stage. Next, the sun is a yellow main sequence star with an average temperature and brightness. So if you haven't figured it out by now, stars have a life cycle. They start as one thing, they end as another. You saw a diagram of that on Monday. Okay, so our sun is in that middle range. It's in the main sequence, okay, because it has average temperature and average brightness. So is it going to get hotter? Is it going to get brighter? Yes. Is it eventually going to die out and become something else? Yes, but that's probably a long, long time away. Okay, so here's the diagram. All right, it says the Hertzberg-Russell diagram, and then you have your different colors. Your main sequence is going to be all of this in the middle right here. Let me move this. All of this in the middle is going to be your main sequence. So you can see the majority of the stars that we know of are just in that general middle area. The sun is literally almost smack dab in the middle of the entire chart. Okay, so you can see as you go up, the brightness gets greater. As you move to the left, the temperature gets hotter. Okay, next one. Come on. Main sequence stars can range from hot and bright to the top left to cool and dim to the bottom right, but they're usually just found in that middle section. Okay, giants. The stage after the main sequence for a small to medium star, fuel begins to run out. Arcturus is a red-orange giant star that is brighter but cooler than the sun. Giant stars are typically cooler stars that are average in temperature. Okay, so you can see they're usually on the right side because they're not as hot as certain stars, and they're about in the middle because they're usually average in temperature. Okay, but this is the stage that a star goes through after main sequence. So our sun would probably end up being a giant once it goes through the main sequence stage. Supergiants. The stage after a main sequence for a high mass star. So if it's a star that's really, really big, it's not ever going to become a giant. It's going to become a supergiant instead. So our sun probably will never be a supergiant because it's an average sized star. Deneb is a white supergiant star that is brighter and hotter than the sun. How do we know that? Because it is closer up, which means it's brighter, and then it is more to the left, which means it is warmer. Okay. Supergiant stars are extremely bright and can range from hot to cold. You have your white dwarfs. White dwarfs are formed when a low mass star has exhausted all of its nuclear fuel and lost its outer layers. So low mass, once it becomes a giant, is probably going to end up being a white dwarf, which means it's not very bright. It's starting to kind of die out. Okay, the layers have gone away, so it's not producing as much energy as it has. Sirius B is a white star that is much more dim but hotter than the sun. So it still has probably quite a bit of temperature, but it's not as bright because it's not exuding as much energy. White dwarf stars are extremely dim and typically average to hot temperatures. Okay, and then next we have just the HR diagram. Okay, so let me go through all of these. So as you move, if you look on your slide, okay, you can see I just have upper left-hand corner and up. Okay, so as you move up, it gets bright. So all three of these on top are the brightest stars that they can be. All three of these on bottom are very, very dim. And then in the middle, you have average. Okay, so that's brightness, because remember, brightness is on the y-axis. So these are very, very bright stars. These are very, very dim stars. Okay, and then you look at temperature, which is on our x-axis. As you move closer to this y-axis, the temperature is going to be hotter. So everything right here by this y-axis is going to be the hottest star that there is. Okay, everything over here on this side of the graph is going to be the coldest star that there is. Okay, so the upper left-hand corner is going to be the brightest star and the hottest star. The lower right-hand corner is going to be the coolest star and the dimmest star. Okay, and then right in the middle is going to be the average. So I want you to take a minute, pause the video, take a minute to look at this and study this. Okay, because tomorrow you're going to have to see this HR diagram and you're going to have to know that the brightness is at the top and the dimmest is at the bottom. Temperature is hottest on the left, coolest on the right. Okay, all right, moving on my end. So we have a checkpoint. So on your document, there are 5 questions that you can answer. You can rewind this video, go through the PowerPoint again to answer these questions, or you can look in your article from yesterday to answer these questions as well. So question 1, what is the HR diagram and how is it useful? Okay, so I want you to take a minute. Okay, I'm just going to go through all 5 of these questions and they're all written on your document as well. So you could just go straight to the document and answer the questions. Okay, question 2, what 4 groups of stars can be located on the HR diagram? Question 3, identify the color of stars from hottest to coolest. Question 4, how could you describe the brightness and temperature of main sequence stars? And then question 5, how does the sun's brightness and temperature compare to other stars? Okay, so I want you to take a minute and I want you to make sure that the entire notes are filled out. All right, again, if you have to pause it, I even give it to you. These informations are, this part is in slide 2, this part is in slide 3. Okay, and then when you're done, make sure you mark as done and click turn in. Okay, tomorrow you're going to use the HR diagram, an actual HR diagram, and answer some questions about the properties of stars. All right, I hope you guys have a wonderful day and you are getting the hang of this HR diagram stuff. Let me know if you need me. Have a good day.